Hello, this is Mrs. Scarpel back with the third and final video for topic 1.5. In this particular video, I am going to be going over how we can determine the degree of a polynomial just by looking at a table or even a graph. So we've done some work with finding the differences from tables in order to determine if a function is linear or quadratic, looking for those constant or linear pattern differences. So what's going to happen here is I'm going to be finding differences until I get a set of differences that are constant, that are all the same number. And however many of those I find will determine the degree of my polynomial. So for example, from -2 to -3, that's a -1. From -3 to -1, that's a +2. From -1 to 4, that's a +5. From 4 to 12, that's a +8. So this isn't a linear pattern, so it's not a degree of 1. Let's see if there's a pattern to these values. -1 to 2, I would add 3. 2 to 5, I would add 3. 5 to 8, I would add 3. And these differences are called my second difference. Because this is the second difference, I can say that the degree of this table is going to be 2. It's going to be a quadratic function. Quadratic functions have a degree of 2. If I take a look at example B, -2 to 0, I add 2, 0 to 10. I should also point out I'm able to do this because my inputs are equal length intervals, meaning it's the same space on my input side. So 0 to 10, I'm adding 10. 10 to 27, I'm adding 17. 27 to 50, I'm adding 23. I don't have a constant value here yet. So now I go to the second difference. I'm adding 8. I'm adding 7. I'm adding 6. I still don't have a constant value happening here. So I'm going out to my third difference. 8 to 7 is a -1. 7 to 6 is also a -1. And because I had to go out 1, 2, 3 times, we call this a third difference. So my degree is 3, meaning it would be a cubic function if I were to graph it. Now, moving on from the degrees, we're going to focus on what makes a function even and what makes it odd. It isn't necessarily the degree of the function. I know I had kind of mentioned the degree with some of you on talking about the end behaviors in class with the work from topic 1.3 or 1.4. I'm not quite remembering which one, but there's a little bit more to it than that. What I should have said when I was talking with those students is an even degree versus an odd degree has these kinds of end behaviors. But if I'm talking even and odd, it has to do with the comparison. So this function notation might be a little difficult to understand. So what I'm going to do is I'm going to write on my graph here what this means in terms of my function. If I have opposite inputs, so you notice I have a negative x and a positive x, those are opposites. So if opposite inputs and remember, this is the notation for my outputs. If I have opposite inputs and my outputs are equal, is what I'm talking about here. If opposite inputs and outputs are equal. That's what we have happening here. So if, for example, if I look at -3, I have an output of 2. So I have -3, 2. And if I look at +3, I have an output of 2. See how my inputs are opposite of each other, but they have the same output? If that is the case, I have an even function. For odd functions, again, it's opposite inputs. So if we have opposite inputs, and my outputs, notice one is going to be positive and one is going to be negative. That means and opposite outputs. So let's see if I can identify a point that isn't necessarily, I think we can use the -2 and the +2. I believe we can use these points here. So at -2, I have an output of +2. At +2, I have an output of -2. Notice my inputs are opposite, but my outputs are also opposite. That is going to give me an odd function. So those are really the phrases I want you to try to build into your head. If you have opposite inputs and their outputs are equal, they're going to be even. So think equal and even going together. If my inputs are opposite and my outputs are opposite, then it's going to be odd. So if both are opposite, it's odd. So let's take a look at how I can do this if I'm just given the expression and I don't want to take the time to graph it. The easiest test is 1 and -1 because those are opposite inputs and we're going to check their outputs. So 2 times negative or 2 times +1 on this first one to the 4th power minus 1 squared plus 5. Well, 1 to the 4th power is 1 times 2 is 2 minus 1 squared is 1 plus 5 gives us a value of, I wrote 4, but that's not correct. -2 or 2 minus 1 is 1 plus 5 is actually 6. So we have an output of 6 when we have an input of 1. Let's see what happens when it's -1. 2 times -1 to the 4th power minus -1 squared plus 5. Well, -1 to the 4th power, because that's an even power, is going to turn into positive. +1 times 2 is 2, minus -1 squared is a +1, so it's just -1. We keep that minus that's in front, and plus 5, and that's exactly what I had before. So my output is 6. So I have opposite inputs giving me an equal output. This is considered an even function. I can do the same thing with B. I'm not going to for sake of time, but you can, the test should always be like -1 and 1. For this particular one with the graph, let's estimate it here. So at -1, well, I guess it does look like it's going through 3. It might come up slightly above 3 when it hits this maximum here. So I'm going to say at -1, I'm at 3. Well, the opposite of -1 is 1, and I'm at -3. I have opposite inputs giving me opposite outputs, so this is going to be an odd function. Now you might be thinking, well, I get some of the same outputs here on D, but if I look at negative 1 is at 1, and I look at where 1 is at negative 3, I don't have opposite or even outputs. So this is neither. This is just, it's a function, but it's neither odd nor even. So the keys are, you have to have opposite inputs first of all, and then you're looking to see if those outputs are equal, then it's even, or you're looking for those outputs to be opposite, then it would be odd. If it doesn't fit those two situations, the function is neither even or odd. It's still a function, it's just not even or odd. It's not going to have symmetry around the y-axis or around the origin. And this concludes the video for topic 5, or excuse me, topic 1.5.